Hey guys, welcome to the Unit 8 test review video. We're going to start off number 1 through 4 with multiplying. So number 1 is a 2 by 2 box because it's a binomial times a binomial. I'm going to draw my box, 2 spots on the top, 2 spots on the side, and fill it in. X and positive 5, x and positive 8. And remember, everything within the box is a multiplication problem. So my first square gives me x squared, then 5x, then 8x, and then 40. I'll pull my terms out of the box. And combine like terms. And that gives me my final answer. Moving on to number 2. We know that number 2 can be rewritten to 3n plus 5 times 3n plus 5. This is 2 binomials multiplied to each other, so we will still have a 2 by 2 box. And I'm left with 3n plus 5 on the top and 3n plus 5 on the side. And multiply within the box. And then pull out all of my terms and combine them together. Combine my like terms to get 9n squared plus 30n plus 25 for my final answer. Number 3. Another 2 by 2 box since it's a binomial times a binomial. 2x and negative 5, 2x and positive 5. Multiply within the box. Pull out all my terms. Combine my like terms, and these add to be 0, so that leaves me with 4x squared minus 25. And then number 4. I do a 2 by 3 box here since I have a binomial multiplied to a trinomial. The binomial is going to go in the 2 spots, and the trinomial will go on the side so that all 3 of the terms are on the same side of the box. I get 3x cubed minus 3x squared minus 6x squared plus 6x plus 5x minus 5. Pull all of my terms out and combine my like terms to get 3x cubed minus 9x squared plus 11x minus 5 for my final answer. Next, we're going to move on to number 5 and number 6 and factor out a GCF. Common factor is short for GCF. So for 45n to the 5th, I'm going to list all of my factor pairs. So if you have trouble finding your factor pairs, remember that you can go into your table, take 45 and divide it by x. Start at 1 and list all of your factor pairs. So I have 1 and 45, 3 and 15, 5 and 9, and that is all of my factor pairs. And remember, I also have 5 n's. I'm going to do the same thing with 5n to the 4th. My only factors of 5 are 1 and 5, and I have 4 n's. And then 20. All of your factor pairs are 1 and 20, 2 and 10, 4 and 5, and 3 n's. Now I'll factor out all of my n's. They both share 3 n's, and my greatest common factor that they all share is 5. So I'm left with 5n cubed. When I divide out 5n cubed from 45n to the 5th, I'm left with 9n squared plus 1n, or just n, plus 4. Number 6. So we're going to break down 50. 1 and 50, 2 and 25, 5 and 10. Break down 10, 1 and 10, 2 and 5, and 1v. And then 40, 1 and 40, 2 and 20, 4 and 10, 5 and 8, with 2 v's. Now we'll look for my greatest common factor. The highest number that they all have in common is 10, and they do not all have a variable, so that we cannot pull a variable out. This leaves me with my GCF being 10. When I divide that out from 50, I'm left with 5. When I divide it from 10v, I'm left with v. And when I divide it from 40v squared, I'm left with 4v squared. Remember, we had the discussion at the beginning of the unit about standard form. You always want your answers to be in standard form. So we'll keep our GCF out front and then just reorder it from highest exponent to lowest exponent. And that is my final answer. Now moving on to number 7, it wants us to factor completely. This is a 4-term polynomial, so we will start factoring by grouping. Since there's already a plus sign in the middle, I can throw the parentheses on. I'm left with n squared, n plus 6, and then 5, and n plus 6. My funny GCF is my binomial, and that leaves me with n squared plus 5. Number 8. I'm going to rewrite number 8 so that I can put a plus sign in between my two parentheses. And pull out my GCF. The GCF of my first group is 7p squared. That leaves me with 5p minus 4. And the GCF of my second group is negative 2, leaving me with 5p minus 4. My funny GCF is 5p minus 4, and then 7p squared minus 2 is left over for my final answer. Moving on to number 9. Since this is a 3-term polynomial or a trinomial, I'm going to do my a times c chart. A times c here is 42, and my b is negative 13. In my table, I'll do 42 divided by x to find all of my factor pairs. 1 and 42, 2 and 21, 3 and 14, 6 and 7. I need to multiply to get a positive, but add to get a negative. The only way to do this is with two negative numbers. So each factor pair will be negative, and then I'll add them together to see if I get negative 13. Negative 6 and negative 7 give me negative 13, so that is what my b will be busted into. So b squared minus 6b minus 7b plus 42. I will rewrite and group so that I have a plus sign between my two parentheses. And then factor out my GCF. I'm left with b minus 6 and b minus 7. Number 10. I notice first thing that my a value is not 1, it is 3. So I'm going to check for a GCF by dividing 216 by 3. That gives me a whole number of 72, so I'm going to factor out 3 as my GCF. And then factor my trinomial from here. A times C is negative 72, and B is positive 1. So I'll take 72 divided by x and find my factor pairs. 1 and 72, 2 and 36, 3 and 24, 4 and 18, 6 and 12, 8 and 9. Remember, when we multiply to get a negative, one number has to be negative and one number has to be positive. In this case, I'm going to be adding to get a positive, so my larger number needs to be the positive number. I'm going to combine all these together, and I see immediately that negative 8 plus 9 is going to give me my value of 1. So I'm going to break up my v into negative 8v plus 9v minus 72. And then group and pull out a GCF. Now I'll pull out my funny GCF, and that leaves me with this. That's my final answer. Number 11. Again, I notice that my a value is not 1, so I'm going to check for a GCF. I'm going to see if I can divide 3 into all of my numbers. I look to 8, and I know that 3 cannot go into 8, so I must not have a GCF. I'll do my a times c chart, so 3 times 4 gives me 12, and my b value is 8. Now I'll get all of my factors of 12, which is 1 and 12, 2 and 6, 3 and 4. We can see that 2 and 6 will give me 8, so now I will bust up my b. 3x squared, positive 2x, positive 6x, and plus 4. Group them together, take a GCF. My funny GCF is 3x plus 2, and that leaves me with x plus 2. And then number 12. I'm going to check for a GCF. The only number that it could be is 7. I'm going to take 41 divided by 7. It does not give me a whole number, so I do not have a GCF. Now I'm going to do my a times c chart. So 7 times 30 is going to give me 210, and my b value is negative 41. This is going to be a larger chart than usual, so make sure you're using your calculator for this problem. Take 210 divided by x and find all my factor pairs. 1 and 210, 2 and 105, 3 and 70, 5 and 42, 6 and 35, 7 and 30, 10 and 21. 14 and 15 is my last factor pair. So when I multiply to get a positive and add to get a negative, I know that both of my numbers in my factor pairs have to be negative. Glancing through this list, I know that 6 and 35 add to be negative 41. So I have 7v squared minus 6v minus 35v plus 30. I'm going to group them together with a plus in the middle and factor out my GCF. My GCF of the first group is v. The GCF of my second group is negative 5. That leaves me with 7v minus 6. And there is my final answer. Moving on to the second page. We see that we're starting with a two-term polynomial or a binomial. So we're going to check to see if this is a dots problem. First, we must verify that there's a minus in the middle, which there is. Now we see if they're perfect squares. R squared breaks down to R, and 144 square root is 12. So this does follow the pattern, and it will leave me with R plus 12 and R minus 12. Number 14, we're going to verify the same thing. A minus in the middle, and check for square roots. Leaves me with 5n and 2. Follows the pattern, so that we'll put it into the dots form. 5n plus 2 and 5n minus 2. Number 15. Check for the pattern. There is a minus in the middle, and then see if 45 is a perfect square. So we're going to take the square root of 45, and that gives me 3 root 5. That is not a perfect square. So to see if we can factor this, we're going to take out a GCF. My GCF is going to be 5, and that leaves me with 9v squared minus 25. Still have a minus in the middle, and I know that 9v squared breaks up into 3v, and 25 breaks down to 5 squared. So when I put it into the dots form, I have 5 times 3v minus 5 and 3v plus 5. Number 16. Verify that there's a minus in the middle and take the square root of my first and second term. So 6x and y. Since they're both perfect squares, we can break it up to 6x minus y and 6x plus y. Now number 17. You see that it starts with 4 terms, so we're going to start with grouping. I'm going to rewrite it. And then take out my GCF. That leaves me with x plus 3 and x squared minus 4. This is a dots problem, so we want to make sure that we break it down. It breaks down to x and 2, so my final answer will be x plus 3, x minus 2, and x plus 2. Take a second and try number 18 on your own. Don't forget to always check for dots at the end. I'm going to start by rewriting with a plus in the middle of my 2 parentheses. and then factor out a GCF. That leaves me with 5m plus 8 and m squared minus 9. M squared minus 9 is a dots problem. So we're going to break that down to 5m minus 8, m squared, and 3 squared. And then 5m minus 8, break up my dots to m minus 3 and m plus 3. Last but not least, we have number 19, 20, and 21. This is a trinomial, but I do notice that my a value is a perfect square and my c term is a perfect square. That breaks up into n and 5. When I multiply those together, I get 5n, and added to itself, it gives me 10n. So we know that this is a perfect square trinomial. Since all of my terms are positive, we know that it will follow in the pattern of n plus 5 times n plus 5, and simplify to n plus 5 squared. Number 20 looks like the pattern of a perfect square trinomial again, with a minus in the front and a plus in the back. I'm going to verify that my a term breaks down, and it does, and my c term also breaks down. Multiply those terms together to get 7m. But notice that my first term is a minus, so it has to be negative. So negative 7m plus negative 7m gives me negative 14m. And that is my final answer. So I'm going to rewrite this to m minus 7 times m minus 7, and that gives me m minus 7 squared. And last but not least, number 21. This is another trinomial that we are going to try to see if it's a perfect square trinomial. My first term breaks down to 2v, and my last term breaks down to 5. I multiply those together to get 10v, add it to itself to get 20v, and that is what I'm looking for. Since both of my signs are positive, it's going to follow in this pattern, 2v plus 5 times 2v plus 5, and that gives me 2v plus 5 squared. That is all